So, hi everyone, and welcome to this lesson. This is the fourth lesson in the first module. Here we are going to talk about what variance is, and we're going to implement it in Python. So, initially, it's a value that tells us how spread the data is, and it tells it to us in squared units. So, for example, if our data was in dollars, variance would tell us how data spread in squared dollars. Formula is here. We just take sum of the every value minus the mean value from the whole data set. It's all squared, and we take the sum of it and we divide it by the number of all of the values. And this is called variance. It's basically squared standard deviation, but we're going to talk about it in the next lesson. And here how we implement it in Python. I've created two random classes, two random data sets. We use statistics module, and we take its function called variance. It's as straightforward as it seems to be, just gives us the variance of it, and we might see that here's variance is 1.2, and here it is almost 9,000. Well, that is because you may see that there is a correlation between those values, squared and variance, because here we take standard deviation, it's this sign without square. And it wouldn't be like 1 exactly, it would be something like 1.1 or something, and when it's squared at 1.25, and the same story works here. And next we're gonna implement that in Python. So what do? We use statistics module, we use load iris dataset from scikit-learn. We load the dataset here, we create a data frame with data from this dataset and columns like feature names from this load dataset. To be exact, I may just show you that load is a dictionary. We can look at the keys of it. We can look at the keys like data, target values. It's what we're gonna predict in machine learning. Frame, target names, that's what we didn't talk about. It's those are names of target values. Feature names, file name, data module. So we care only about data and feature names, so we created a table like that. And let's imagine a situation we just wanna understand how sample length varies. Like, is this data varied? Because, for example, you may see that here's 4.9, 4.7. Maybe next values would be tens of thousands, and let's just see the variance and how the data is spread. It would be valuable for looking for outliers and for just understanding the structure of the data. So we just used statistics module like that, variance function like that, and we want to see some like data set, and these things are for length in centimeters. We're gonna look at that. And there is a problem. I'm sorry, I misspelled it. Variance like that. And it's 0.68, so the variance is basically extremely low. We can even we can import NumPy. I'm talking a bit about the next lesson, but whatever. We can import NumPy as NP. Then because this 0.7, it's in centimeters squared, and just understand how squared the data is in terms of just centimeters. We can take the square of it using np.squaret. It will be a fuck up if it's not in NumPy. No, it's in NumPy, so it's basically almost 1. So so our data is not varied at all, because you may see that here is number 5, and the variance is almost 1. We may even see the maximum value like that data set, like that. Sorry, I'm a little bit slow, but like that. It's 7.9, so it's not actually varied at all. So you may see this. So that was all. This video is a bit short,